Hello guys, so in this video what I'm going to do is I am going to do various problems using, so basically solving right triangles, or not right triangles, I'm sorry, solving oblique triangles using law of sines. So usually when we have, when we have a triangle where we're given two angles and we're has to solve for a side, it's a little bit harder to use right triangle trigonometry. I don't know if it's impossible, but I know that it is harder to do so using right triangle trigonometry. So that is why they include something called the law of sines. And the law of sines states that if we have a triangle, let's see here, if we have a triangle, let's just say ABC, right? And we have angles, so that those are the angles, ABC, right? And then we have a side A, a side C, and a side B. That means that sine of A over A should equal sine of B over B. So sine of my angle B over my side B is equal to my sine of my angle C over my side C. That is what the law of sines says. This is a really important formula to remember for law of sines. Now, in this particular problem, we're asked to solve for x. And obviously, we can't, at least I don't think I can do right triangle trigonometry, because if I do so, honestly, we have this unknown side here, we can call it h, and there's just no way to do this, given this information. It's impossible. We can, honestly, yeah, we don't even know any of the sides, so how would we do this using right triangle trigonometry? That is where law of sines comes in, because sometimes when we're given a triangle like that and we cannot solve it using right triangle trigonometry, we ask, well, what else do we do? Well, that is where law of sines comes in. And this is important to know, for trigonometry. You have to know how to do law of sines and cosines. I do believe you use it, maybe in Calc 3, I don't know, I can't remember. But you definitely use a lot of trigonometry in Calc 3, or in Calc 1 and 2, and especially Calc 2, and this is important to know. So, with that being said, let's get started on this video, and I'm going to do a few examples. So we're given that, we're given these two side lengths. Let's just call this ABC, triangle ABC, right? And we're asked to solve for x, and we don't know, obviously we can't use right triangles, so we have to use the law of sines. Now, I can say the following: sine of A over x, which is the side A, is equal to sine of C over 10, right? Which is my side C. So if you think about it, this is C. I can kind of make this C like that. And then A can be this one. So this is A. And let's just say this is X right here. Okay. So that you can kind of see the pattern, or the way that I'm doing it. So I can say, well, sine of A over X will give me sine of C over 10. We know that C is equal to 10, and my angle C is equal to 50 degrees. And I also know that my angle A is 70 degrees, and I want to know what X is. Okay, so I'm gonna do what we call cross multiplication. So, or actually, I'm gonna fill out the information so I can say sine of my angle A, which is right here. It's like right here. I'm gonna put 70 for that, so sine of 70 degrees over, and then I have X, right? So X, which is what I'm looking for, is equal to the sine of my angle C, which is 50 degrees, over my side C, which is 10. So if I make this like, I should make this the right color so that y'all are not confused as to what this one is. This is C. So this is what C is. Okay. Now, be like this. So you're gonna do cross multiplication. So you're gonna say 10 sine of 70 degrees is gonna be X sine of 15 degrees, right? So 10 times sine of 70 is going to be X times sine of 50, right? So then I can divide both sides by sine of 50 degrees, and I can get that X equals 10 sine of 70 degrees over sine of 50. Now, I have to get my calculator and calculate what that is, because I obviously, you know, you can't do that in your head. So, like, even if you could, it's impossible to do it in your head, so you have to do a calculator. So sine of 70, 10 sine of 70 over sine of 50. So we get, and it should be in degrees. Your calculator should be in degrees. X will equal to 12. I'll say, give me 1 second. 1 second. Yeah, so if we round to the nearest tenth, this should be that X should be 12.3 units. They don't really give us the metric, like what types of units it is, so we can just say units. Let me do another example. Okay, so let's do this one. So obviously they didn't label the triangle, but I'm gonna label it A, B, C. Okay, and it's the same idea. This is with law of sines, so I can say sine of, so okay, here's the thing. What you're gonna do first, so the thing is, if you do sine of A over, I'm gonna say X because that's the side opposite that, and then sine of B over B, and then equals sine of C over 6. It's, so what I'm trying to say is that you need to solve for one of the angles first before you can solve for the side that you're given, because if you don't do that, you're, for example, if I say sine of 25 over X gives me sine of C over 6, I need to know what C is to solve for X. I need to know what angle C is. Notice that we have two angles. We have 25 and 120. And if you remember from trigonometry and geometry, that the degrees of the total degrees, or the total, like the angles in a right triangle or in any triangle is 180. So you can say that angle C plus angle B plus angle A equals 180. Angle C plus 120 plus 25 equals 180. Because angle B is 120, angle A is 25. And you have angle C plus, and you're going to say 145 equals 180. So then you can solve for angle C. And you get angle C equals 180 minus 145, which is 35, I believe. Yeah, 35. So angle C is 35. So we can kind of fill that out. 35 degrees right there. Okay, now we can do law of sines to solve for x. So now that we have our angle C, we can use law of sines to solve for x. So then that means we're going to have sine of 25 over x will equal sine of 35 over 6. Please make sure that when you do the law of sines, you can do it either as sine of A over A equals sine of B over B equals sine of C over C. Do not do A over, or I'm sorry, like, or you can do it the other way, actually. You can do it A over sine of A equals B over sine of B equals C over sine of C. These two are the same idea, okay? They're the same idea. So I can say 6 sine of 25 equals x sine of 35 degrees. So then if I divide by sine of 35 degrees, I get x equals 6 sine of 25 over sine of 35, right? And that'll give me, so let's see here, 6 sine of 25 over sine of 35, right? And that's approximately 4.42. So x is approximately 4.42 units. Okay, that is how I solve for x. Okay, so notice what I had to do here. I had to first solve for my angle, and then I had to solve for the side. When you have, so what I'm trying to say is, like, take advantage of solving for all the angles, unless you have to do law of cosines, which, in case, we're not going to do that in this video, but, you know, try to solve for all the angles, unless they ask you, like, you know, solve for the angle using law of cosines, or, you know, in which case you would have to use law of cosines. But any case where they give you two angles and then there's one angle that's unsolved, you know, at any case, solve for that angle, just like I did here, and then do law of sines. So yeah. So let's move on to the next problem. Okay, so this one, we have to solve for x again. So it's the same idea as the last problem. So remember what I said. We have to solve for the angle first before we can solve for the given, or for the side that we're trying to solve for. I'm going to solve for this third angle here, that, this one here. first. So I'm gonna say, and also, this is not a 45, 45, 90 triangle. Do not get tricked. If I split this into two right triangles, this gets halved by 2, so we're not gonna really end up with a 45, 45, 90 triangle. It's gonna be like, I don't know. It's gonna be, we're not gonna do that. Like, please do not try to do that. Just do, like, do law of sines like we've always been doing. Now, if there are problems where they're asking you to use it or solve it using right triangle trigonometry, please let me know and I will make a video on how to do that. I might look for some problems like that on a textbook. I'm not sure though, because I haven't seen. I know I did it doing when I was in trigonometry. I did solve for certain angles and certain sides, you know, by what is it called, by right triangle trigonometry, but I never did it doing like, the thing is that I've never made a video on it, so yeah. So this one, we're gonna say that 75 plus 45 plus, let's call this angle C. Angle C is equal to 180. Now, 75 plus 45, that's 120. And plus angle C is equal to 180. So now using algebra, we're going to solve for angle C. So minus 120 here, minus 120 here. We get angle C equals 60. So this is going to be 60 degrees. Angle C is 60 degrees. And now we can use law of sines to solve for x. So we can say sine of 45 over x equals sine of 70, or I'm sorry, sine of 45 over x equals sine of 60 over 15. So now we can say 15 sine of 45 equals x sine of 60. Okay. And might I add that we're rounding this to the nearest tenth. So, I mean, you can use the unit circle. Like, if you know what sine of 45 degrees is, you can do that, but, and then sine of 60, but honestly, I wouldn't bother because you have to round it either way to the nearest tenth. So, I mean, unless they tell you, okay, use, you know, unit circle properties to solve for this, then yeah, go ahead and do that, but they're not telling us that. We need to round it to the nearest tenth. So now all we have to do is solve for x. So we have 15 sine of 45 equals x sine of 60. So to solve for x, we just divide by sine of 60 on both sides. Okay. And if you enter that in your calculator, so x equals 15 sine of 45 over sine of 60. And if you enter that in your calculator, you will get the following. So 15 sine of 45 over sine of 60. It's approximately, and they said to the nearest, hold on. Okay, it said round to the nearest tenth. So this will be, let me see. I want to say it's 12.3, but I'm not. Give me 1 second, guys. Okay, it's approximately 12.2 units. So x is going to be 12.2, okay? That is using law of sines. Okay, so we're going to do, I believe, we can do one more example. So, give me 1 second. Okay, so this is going to be the last example that I do on this video. There are more examples, but I am going to do that for another video. Like, there's one where you have to find the radius, and we'll do that for another video, but this is going to be the last example for law of sines. So, we're asked to solve for x again. Now, this time, it's gonna be a, because I don't think in the last examples we were doing a bunch of sides. We never did angles. So this one actually asks us to solve for an angle x, right? So this is a little different from the previous problems. We're still going to use law of sines. If I label this A, B, and C, I can say that, and then this is A, this is B, C. I can say that sine of x over 5, right? So sine of x over 5, which is kind of like this. Okay, is equal to sine of 98 over 10, which is really this and this, right? It's the same idea. Sine of x over sine of x over 5 is sine of 98 over 10. Okay. Now we have to solve for we have to solve for x, excuse me. We're gonna say, so cross multiplication, right? So 10 sine of x equals 5 sine of 98. Okay. And then we're gonna divide by 10. And then we have sine of x is 5 sine of 98 over 10. I would leave it the exact way that it is. I mean, you can simplify the 5 over 10, but don't try to make, what I'm trying to say is don't make sine of 98 into a decimal. Do not do that. Because if you do that, I mean, honestly, I wouldn't do it. So you're gonna do sine inverse of, so basically sine inverse of sine of x is equal to sine inverse of, and then you're gonna do 5 sine of 98 over 10. It doesn't matter whether or not you simplify your fraction. It really doesn't, as long as you do sine inverse of both sides. Okay, so sine inverse of 5 sine of 98 all over 10. And that should give you approximately, so I believe they told us to round to the nearest 10th, if I'm correct. Give me 1 second, guys. So that means that these two cancel out, so x should be approximately 29.7 degrees. Okay guys, so that is how you do law of sines. These were some very basic examples. I mean, this is just for those of you that are kind of like you don't really know what law of sines is, these are just some very basic examples. I will do some more complicated examples in the next